My talk title today is The Rock of Ages and the Age of Rocks, but I've been told I have liberty to apply those concepts in a metaphorical way. The Rock of Ages is, of course, God. The ages of the rocks is a way of referring to scientific inquiry. And what I want to talk about today is what we can know or not know about the reality of God from, as St. Paul puts it, the things that are made. What does the natural world reveal about the reality of God or not? In talking about this, I'll be going a bit further than what I usually talk about in just making a strictly scientific case for intelligent design. I'm going to look at how the case for intelligent design might fit into a broader case for theistic design, or for the reality of God as an explanation for not just developments in biology, where I spend most of my time working, but in the scope of many scientific discoveries. So I'm going to put my work on intelligent design in a broader context today. Now, many of you may be familiar with a group of authors known as the New Atheists. How many have heard of these folks? Okay, Christopher Hitchens, who unfortunately recently passed away, Sam Harris, Richard Dawkins, perhaps the best known with his book, The God Delusion. And Dawkins, in fact, I think typifies the perspective of these folks, because what his main claim is that science, properly understood, renders belief in God untenable, implausible in the extreme. If you understand, Dawkins argues, that life is the result of a purely mindless, undirected Darwinian process, then you must also understand that life merely gives the appearance of having been designed. He famously says that biology is the study of complicated things that give the appearance of having been designed for a purpose. What's the key word in that quotation? Obviously, well, purpose, except it's the appearance for him. The purpose is an illusion. It's the appearance of design, the appearance of a purpose. And why is it merely an appearance? Why is it an illusion? Because there's an unguided, undirected Darwinian mechanism that has produced that appearance without itself being guided or directed in any way. And so for Dawkins, since design is an illusion, the possibility of a designer is delusional. He argues that the strongest reason for believing in the existence of God was always the argument from design, the evidence from nature. And now that we know that that evidence is not pointing to an actual designer, but instead to an undirected process that merely mimics the power of a designing intelligence, we can safely conclude that God either does not exist or has left no evidence whatsoever behind of his existence, such that to believe in such a being is effectively delusional. This is the new atheism. Science, properly understood, undercuts belief in God. It conflicts with belief in God. Now, obviously, the Dawkins perspective conflicts with the biblical view. If you go to the Old Testament, you find passages like Psalm 19, in which the psalmist says, "The heavens declare the glory of God, and the skies proclaim the work of his hands." Something about nature, says the psalmist, is pointing to the reality of the Creator beyond nature. You get the same perspective in the New Testament. Romans 1 says, "For since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood," and I like to italicize the last part, being understood from what has been made. The things we study in science, the things of the natural world, are part of what reveals the reality of God and his attributes, his power, his wisdom, his reality. So obviously, this new atheistic perspective runs directly counter to the biblical understanding of the relationship between science and nature on the one hand and God on the other. Science, which is the study of nature, reveals the reality of the Creator. That's the biblical view, directly opposite to the view of Dawkins and the New Atheists. Of course, that's not too surprising. They are writing polemical works very directly opposed to a theistic, biblical, Christian view of reality. What may be a little more surprising is to realize that the perspective of the new atheists is also diametrically opposed to the perspective of the early modern scientists, the scientists who are responsible for the origin of modern science. And here I think of people like Robert Boyle, the famous chemist, Johannes Kepler, the famous astronomer, who said, by the way, that scientists, or that were called natural philosophers at the time, but he said that natural philosophers have the high calling of thinking God's thoughts after him. Sir Isaac Newton, Galileo, many of the leading scientists of the period of time called the Scientific Revolution, when modern science was getting going, were devout men of faith and typically men of Christian faith. And moreover, they had, I have on the screen a slide from the front piece of a book called, that's actually a paraphrase of the book of Romans. This was written by John Ray, who was one of the founders of modern biology. And the book title is The Wisdom of God Manifested in the Works of Creation. It's got that old-fashioned F for an S, so you'd pronounce that manifested, I guess. Okay. So this shows, though, the deep connection in thought between the biblical understanding of the relationship between the natural world and our understanding of the Creator that was part of the way that scientists were thinking at the time. They had a watchword, in fact, that was part of the inspiration for science in the first place. And this watchword was intelligibility. There was a deep-seated conviction among the scientists who were founders in the various disciplines of science that nature was intelligible because it had been made by a rational intellect, namely, it had been made by God. And because God was rational and He had a rational mind and had made us in His image such that we had rationality, we could indeed think God's thoughts after Him. We could perceive the rationality, the order, the design that had been built into the universe. That was the very foundation of science. Very much the opposite of the view you find with these new atheists. A couple years ago, actually about 10 years ago now, I had an opportunity to testify before something called the U.S. Commission on Civil Rights. And they were investigating whether or not there was viewpoint discrimination in the teaching of biological origins in the public schools. Any thoughts on that? When I heard of the hearing, my first thought was, I wouldn't have thought you needed a hearing to determine that. If you open up the standard textbook, you get the Darwin-only full-orbed Alleluia chorus in virtually every textbook that's used in public high schools. Nevertheless, I testified and got quite a grilling at first because I not only am a Darwin skeptic, I favor the alternative idea of intelligent design. And one of the commissioners began to ask me a lot of questions that seemed to reflect a lawyerly strategy of impeachment, as if he was trying to impeach my credibility. Well, did your supervisors at Cambridge know that you had these views? Would they have approved? The questions like that. And at first I thought he was very much opposed, but then he took a more sympathetic line in the questioning, and he said, now isn't this view of intelligent design that you hold essentially the same idea that was advanced by Johannes Kepler and Robert Boyle and Sir Isaac Newton? And when I heard the name of my heroes, I perked up and I said, well, yes, it is. That's exactly what they believed. And he said, well, I was interrupted at that point by my opposite number at the hearing. And she said, well, it's true that Newton believed in intelligent design, but he took great pains to keep his ideas about religion separate from his science. Notice how that was framed. Intelligent design equals religion. Now, I'm not one of these people that memorizes blocks of texts or even Bible verses that well, But it just so happened at this point in time, I'd been working on an essay, which I had in my briefcase because I'd finished it the night before, and it had a quotation from Sir Isaac Newton in it. And I found myself saying something that sounded very impressive. I said, well, but that's not true. In the general scholium to the Principia, I said. Doesn't that sound impressive? All that means is the introduction, but, you know, the commissioners didn't know that. And so I said, in the general scholium to the Principia, Sir Isaac Newton said the following, and I'm going to read you the quote. I went back and looked at the transcript. I didn't have it quite word for word, but it was close enough. Here's the quote from Newton. He said, I said one other thing. I said, in the general scholium to the Principia, arguably the greatest work of physics ever written. Okay. And it arguably is. It's either Newton or Einstein, you know. So, and this is what Newton said. He said, though these bodies, he was talking about the fine-tuning of the planetary system, the way all the planets are delicately balanced to maintain this beautiful, stable orbit. And he said, though these bodies may indeed continue in their orbit by the mere laws of gravity, yet they could by no means have first derived the regular position of the orbits themselves from those laws. Thus, this most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being, capital B. Yeah. Now, I simply made the point in follow-up that right in the introduction to the greatest work of physics ever written, or arguably so, Newton was making arguments for intelligent design. He did not separate his support for intelligent design or the evidence for intelligent design or his argument for intelligent design from his science. It was built into the very fabric of one of the greatest works of physics ever written. So that raises a question for us. Interestingly, in the hearing, I was a very young professor at the time, not nearly as well known as my opposite number, and the commissioners knew very little about intelligent design, so there was probably a huge bias against our point of view. But after I cited this passage from Newton, there were these smiles that broke across the faces of several of the commissioners, and they started nodding as if, this could be more interesting than we thought, you know. So, anyway, this little story, and specifically the quotation from Newton and from John Ray and our understanding of the history of science raises a really obvious question. How did we get from Newton to Dawkins? How did we get from the idea that nature displays the handiwork of the Creator such that you can tell by examining it and looking at it, to the idea that nature shows there is no Creator and that belief in God is tantamount to a delusion? That's a pretty big shift. Well, as always with things like this, there's a story. And in this case, it's a story of intellectual or scientific history. And it's largely the story of what happened in the 19th century. And it starts actually in the field of astronomy, where Newton himself had worked, astronomy and physics. There was a French physicist named Pierre Laplace who wrote a book right near the turn of the 1800s. It was published in 1799. It was called The Celestial Mechanics. And after its publication, Laplace was called into a meeting with Napoleon, the emperor. Now, in the book, The Celestial Mechanics, Laplace attempted to do what Newton, in that last quotation, said you could not do, which is explain the origin of the solar system as the result of purely unguided natural forces, the basic laws of gravitation. He had a theory called the nebular hypothesis that suggested that the gravitational forces had caused gases to congeal in a purely natural way. There was no need for an intelligent and powerful being fine-tuning the planetary orbits. Gravity could explain it all. Now, of course, for Newton, gravity was a manifestation of God's ordering of the universe, but Laplace was now moving in a different direction. Now, he's called in before Napoleon, or at least so the story goes. Historians are not really sure whether this happened or it's merely apocryphal, but it's a good story either way. And Laplace comes in before Napoleon, And Napoleon says to him, Pierre, you've made French science very proud. You've shown up Sir Isaac Newton and the British. Remember, they were at war at the time. And you've written a phenomenally important book. But I have one question for you. I've read Newton too, and I find mention of God on nearly every page in his book, but I find no mention of God in your work. And Laplace is said to have puffed himself up and then said, Sire, I have no need of that hypothesis. That's my French accent. Sorry, it wasn't very good, was it? He has no need of that hypothesis. What hypothesis? The God hypothesis, the design hypothesis. He thinks he can explain the origin of a very important event in the history of the cosmos, the origin of our solar system, by reference to purely unguided, undirected natural forces and natural laws. Now, this approach to understanding the history of the cosmos extends from physics and cosmology, eventually into geology, and finally into biology. Perhaps the most important figure in this kind of grand synthesis that arises in this 19th century is, of course, Charles Darwin. In a leading biology textbook, college biology textbook, written by Douglas Fatuma, he explains it this way. He says that Darwin, by coupling the undirected, purposeless variations to the blind, uncaring process of natural selection, was able to make theological or spiritual explanations of life superfluous, unnecessary. He too, Darwin also, had no need of that hypothesis, the God hypothesis or the design hypothesis. His mechanism of natural selection could do what previous biologists thought only intelligent agents could do. Natural selection could produce the appearance of design without being guided or directed in any way. So when you step back, when historians have stepped back and looked at this roughly 100-year period of the 19th century, historians of science have seen that a whole series of new developments in science came online in which scientists put forward theories that attempted to explain the origin of very significant events, the origin of the solar system, the origin of the mountains and the canyons and the great geologic features, the origin of all the new species, and eventually even the origin of life in the human species, all by reference to purely unguided, undirected processes. And these were all scientific theories, various types of evolutionary theories. And when you strung them all together, you had a seamless story you could tell about the history of the cosmos, from the beginning of the solar system all the way to the origin of man and woman. And that way of looking at the world, which was in the 19th century very much a matter of the science of the day, also became the foundation of a great worldview, of a philosophy. And that philosophy has a name. It's sometimes called scientific materialism. It's the idea that science supports a materialistic worldview. Now, let's talk about what I mean by a materialistic worldview. How many of you are familiar with the worldview catalog called The Universe Next Door by James Sire? It's a wonderful way to get into, to understand the different worldviews, the different major philosophical systems that vie for our allegiance today. But Sire has a great way into this. He talks about 7 different questions that every worldview must answer. And a worldview, by the way, you're in a Renewing the Mind conference, so I'll ask this rhetorically. I don't expect people to shout out, but can you define a worldview? Sire defines it operationally in a very effective way. He says a worldview is a set of more or less coherent answers to some fundamental questions. Not questions about, for example, who's going to win the next election, or who won the World Series, or the composition of the chemical formula for salt. Not questions like that, but more fundamental questions like, what is the thing or the entity from which everything else comes? What's the nature of the external world around us? Is it an orderly system or a chaotic system? What's the nature of a human being? Are humans free to choose, or are they totally determined? Those kinds of questions. And of those worldview questions, Sire argues that the one that is most fundamental is what the question he calls the prime reality question. Technical philosophers call that the subject of metaphysics. And that prime reality question is this: what is the thing or the entity from which everything else comes? Now, can you see that what was going on in 19th century science was, in effect, giving an answer to that foundational worldview question? So when you're looking at these questions of origins, you're looking at questions that are scientific, but they're also incorrigibly philosophical at the same time. The 19th century scientific answer to the question of the prime reality was, well, in the beginning were the particles. And the particles became complex stuff. And that complex chemical stuff eventually arranged itself and became a living cell. And that living cell evolved by undirected, unguided Darwinian processes and produced more complex forms of life. And eventually, one of those very complex forms of life, namely human beings, conceived of the idea of God. In other words, the materialistic worldview is, it has God in the system, but God is an illusion, the God delusion. God is only an idea in the mind of man. What's fundamentally real, what is the thing from which everything else has come, is matter and energy. It's the material stuff of which the physical universe is made, which has been here in the materialistic way of thinking from eternity past. In fact, we shouldn't say in the beginning were the particles. If we're going to be consistent scientific materialists, we should say from eternity past were the particles. There was no beginning. Okay? Just as Christians and Jews believe that God is the eternal self-existent thing from which everything else came, the materialist believes that matter and energy are the eternal and self-existent thing from which everything else comes. Now, the point is that by the end of the 19th century, elite opinion in science and philosophy, leading intellectuals, were coming around to this materialistic worldview, and they believed that the materialistic worldview had the support of science itself. It was all these origins theories that seemed to underwrite this way of looking at the world. So in a real sense, in an important sense, the new atheism is not new at all. The new atheism is actually repackaged late 19th century scientific materialism to make bestsellers. It's an old ideology, which is, though I must acknowledge, very much still with us. The dominant thought form on the college campus today, at the university level, research universities, I would say the dominant thought form in most of the elite media culture and information culture, in the elite media, the law schools, the courts, even many seminaries, is this either, we sometimes call it naturalistic worldview or materialistic worldview. And many things follow from it. If you hold that there is if you hold that the fundamental reality is matter and energy, and that there is no God independent of the universe that brought it into existence, it's very hard to also hold to an objective morality, because there is no standard above us all to which we can appeal. Instead, we just do what we've been programmed to do by the particles in motion, by the deterministic material forces that affect us. We don't have freedom of choice, and we can't even begin to talk about what the oughts are that are implied in moral statements. So the worldview that you hold ends up affecting your view of ethics, your view of the sanctity or lack thereof of life, and many, many other issues. And this materialistic worldview is the dominant way of thinking today, especially in the universities, but because the universities are so central to our culture in many, many other spheres of elite culture. And when students go off to college, guess what happens to them? They've come from a religious home where they believe in God. Well, they very quickly encounter this very opposite way of viewing everything. And a lot of kids feel like they didn't get the memo. All these smart professors are thinking one way, and it's so opposite to what they were raised with. And Del Tackett, who's here with us today, will tell you that that freshman year in college can be a killing field for faith. Alarming statistics on the number of Christian students who lose their faith in the very first year of college. They're encountering a cognitive dissonance, and it's very acute. Well, so far I've been giving you, in a way, a lot of bad news, okay? That this materialistic way of thinking is the dominant way of thinking, and up until recently, it has had the support of modern science. By the way, I have the picture on the screen is a worldview, a diagram depicting the materialistic worldview. It might help you to see it pictorially. The circle represents the physical universe. The pendulum represents the laws of nature. Everything else in the circle represents all the different aspects of physical reality. The key thing in the materialistic worldview is the assertion that there's nothing beyond that physical sphere. There's no God, no creator, no purposeful designer who brought the universe into existence. The universe is eternal and self-existent. So that's the picture of reality that's very much still with us in the academy, very much still with us in the culture. It came from developments in 19th century science. The exciting news is that the testimony of science has shifted dramatically since the 19th century, when this worldview became dominant. And so even though this worldview still is culturally pervasive, even dominant in the universities, the basis for the worldview has evaporated. That is to say, there have been a series of discoveries in modern science, in very recent science, that undercut this way of thinking altogether, that challenge the materialistic worldview, and in fact, I'm going to argue, support a theistic worldview, suggest the reality of a creator beyond space and time who is intelligent and also active. Now, I'm going to give you a quick survey of some of these scientific discoveries. The first one occurred in the field of cosmology, and it's often associated with the work of Edwin Hubble, a Belgian priest named Father Lemaitre, and other scientists working in the 19-teens and 20s. Hubble is famous now, even today, because there's a telescope named after him. Somebody chuckled when I said that, because if you followed the news, that poor Hubble telescope was always broken when they were trying to get it up and running. How you like that? Make a great discovery in science, get a telescope named after you, and then it's always in the news because it doesn't work. But anyway, Hubble came into astronomy in the 1920s at a very propitious time. It was at just the time that astronomers were gaining access to these large dome telescopes that were able to resolve very tiny pinpoints of light in the night sky. Prior to Hubble and the scientists who were looking into the night sky in the 1920s, there was debate among astronomers as to whether or not the Milky Way galaxy in which our solar system resides was the only galaxy, or whether there might be others beyond it. Hubble resolved that issue as he also resolved these points of light, because as he looked through this great dome telescope at the Palomar Observatory at Mount Wilson in Southern California, he was able to determine that little points of light that had been viewed through ordinary telescopes before and just looked like little points actually revealed galaxies, whole galaxies with hundreds and millions of stars. And so the picture behind us is a spindle nebula, a type of galaxy. And he saw spiral nebula, many different galaxies in every quadrant of the sky, such that today astronomers have something they call the Hubble Deep Field. And it's a picture of the night sky. And if you take a little picture of any part of the night sky, on the picture behind, you'll see a little square box, a little quadrant. Now the next slide is going to be that quadrant amplified further, magnified further with telescopic magnification, and you see that even in the tiniest little square in the night sky, there are galaxies galore. And so the first thing that Hubble determined was that we live in an immense universe. It was grand in scope beyond our wildest imaginations, galaxies in every direction. Now that was just awe-inspiring. But there was also a very theoretically and philosophically significant discovery that he made that was closely associated with this. And that is the discovery that these galaxies are moving away from us. In every direction of the night sky, the galaxies are receding. And the evidence for that came from something called red shift. It was light, it's that the light coming from these distant galaxies, like this auditorium is a great visual aid if you look up at just the the canisters of light. You could imagine them as galaxies in every direction. But the light coming from those distant galaxies was redder in its hue, in its electromagnetic spectrum, in its color, than it would otherwise be if the galaxies were stationary in relationship to us. How many have heard of the Doppler effect? You know of that from if you have a train moving away from us, the sound of the train whistle, it will drop in pitch. Well, the drop in pitch corresponds to a shift in wavelength. Up in Seattle, we had these, I don't know if you can talk about beer commercials in a church, but why not? We had these beer commercials for Rainier beer, and they had these guys dressed up as beer cans that rode around on motorbikes. And when they would, at the end of the commercial, they would ride off into the sunset saying, Rainier beer, and you had the Doppler shift happening. I'm probably the only person that watched that and thought Doppler shift rather than let's go get a brewski, Okay. Anyway, the same thing, what was my point? Yes, the same thing happens with light. That was the point. That if you have an object receding away, the light coming from that distant object will stretch out, you get longer wavelengths, and those longer wavelengths of light correspond to the red end of the ultraviolet spectrum. If you pass that light through a prism, the red light is longer in wavelength and indicates a recessional velocity when it's coming from a distant object. Now, this was an amazing discovery. And in every direction of the night sky where they checked this out, it was the same thing. Every galaxy was moving away from us. Now, what do you infer from that? Well, I have a visual aid, and it's not a beer can. Okay, it's a balloon. And this Hubble, got to thinking about this, and he realized that if the galaxies, and I've drawn these little spirals on the balloon, okay, so think going forward in this is the forward direction of time, what's happening? If all the galaxies are moving away from us, that means the universe must be expanding outward in a kind of spherically symmetric expansion. So as you go forward in time, you get the universe getting bigger and bigger and bigger. Now, what happens if you wind the clock backwards, like the Saturday morning cartoons where they make the characters go backwards? Okay. What if what the technical term is back extrapolate in time? Well, if you go back 1,000 years, is the universe bigger or smaller? Okay. And as you go back and go back and back and back and back, the further you go back in time, the universe gets smaller and smaller and smaller until eventually you reach the beginning point of the expansion, where everything was congealed together. And Hubble realized that an expanding universe implied a finite universe, a universe that actually has a beginning in time. Now, this was a really significant discovery because at the very same time, on the other side of the country, there was this physicist with bad hair named Albert Einstein. Okay. And Einstein had come to the same conclusion that the universe must have a beginning, but then he said, no, that cannot be right. And Einstein came to it on the basis of his theory of general relativity, which was a theory of gravitation. And the equations of his theory suggested that the universe must be expanding outward and decelerating in order for all of the math to work out. But when he realized that if it was expanding outward, it must have had a beginning, he said, no, that can't be right. So the force of expansion, so then he posited an arbitrary force that was meant to counteract the force of expansion in just the right measure so that the universe would be static and therefore could have existed eternally without expanding or contracting. This arbitrary force was called his cosmological constant. He picked a very precise value so it would counteract the force of expansion that he thought must be happening to make his gravity equations work out. So by a long process of theoretical reasoning in advanced physics, Einstein had come to the conclusion there must be a beginning, and then said, no, that can't be right, and then he introduced an arbitrary factor to try to eliminate the implication of a beginning from his own theory. When I was a physics student, we used to call this dry labbing, where, you know, the professor gives you an experiment to do, and you know what the answer is supposed to be, but you do the thing with the hockey pucks on the air table, and it's not coming out right. And it's getting near the end of the period, and you want to go to dinner, and so what do? Now, I'm not saying I ever did this, okay, but I know some people who did. You know, you take the pen and you adjust the values so that they match the theory, okay? That's called dry labbing. That's essentially what Einstein, one of the greatest physicists in the history of the world, that's essentially what he did. He fudged, okay? Because he had a preconceived idea that the universe must be eternal. And that was so strong, it was such a strong philosophical predilection that he adjusted the science to try to meet with that. Then Hubble comes along and discovers that the universe actually is expanding. There must have been a beginning. And so he invites Einstein out to California to view the evidence that he'd been viewing through this grand telescope. And there's some famous newsreel footage where Einstein comes out and he looks through the telescope with Hubble in the background smoking his pipe. And he comes out and meets the media and says, I now see the necessity of a beginning. That's the German accent. That was a little better, didn't you think? Yeah. Of a beginning. I have an actor friend who coaches me on these things. It's really pathetic. Okay. In any case, Einstein gets it and later says that his cosmological constant, his little fudge factor, was the greatest mistake of his scientific career. In essence, the heavens talked back. And the testimony of the sky was that there was a beginning to the universe. Now, this has just set in motion a whole series of really interesting debates and discussions in the field of astronomy and cosmology. And alternative theories were proposed. One astronomer, famous British astronomer named Arthur Eddington, said this. He said, philosophically, the notion of the beginning of the present order is repugnant to me. I should like to find a genuine loophole. I simply do not believe the present order of things started off with a bang. The expanding universe is preposterous. It leaves me cold. Now, sorry. I'll stick to the science from now on, sorry. Anyway, this is in psychology a theory known as denial. Did you notice how he started this statement? It's philosophically, I don't like it. It's not the evidence says thus and so, it's philosophically I don't like it. What's the philosophy that makes the discovery of a finite universe repugnant? It's this materialistic view we've been talking about, or naturalism, the idea that it's matter and energy from eternity past. If Hubble's results are correct, they're suggesting that matter and energy are not from eternity past. There was a beginning to the expansion. Now, that issue was even further clarified by another famous physicist named Stephen Hawking. And writing in 1968, a famous scientific paper, he and another physicist from Oxford, you know Stephen Hawking, the famous physicist with the Lou Gehrig's disease in the wheelchair, okay? And he's at Cambridge. Roger Penrose, a colleague at Oxford, in 1968, the two collaborated and wrote a famous paper showing that not only was there a beginning to the universe in time, but there was also a beginning to space itself. They did something, and there won't be a test on this afterwards, so don't worry, but they solved the field equations of general relativity. They solved some of Einstein's equations about how gravity works. And you can kind of imagine this. As you go back further and further in time, there would be more and more matter. See, Einstein's theory was that as matter gets bunched together, a concentration of matter causes a curvature of space. That was Einstein's theory of gravitation, and causes preferred lines of trajectory around concentrated matter. So if you are thinking that way and you think, as you go back and back in time, as matter gets closer and closer and closer to being all bunched up, space is going to get curved more tightly and tightly and tightly. And what Hawking and Penrose showed is that the curvature of space-time approaches an infinite as you go back in time a finite amount of time. As you get back far enough, the curvature of space becomes so tight that it's infinitely curved, infinitely tightly curved. Now, an infinitely tightly curved space refers a not so curved space. Got a big sphere, a little tighter, keeps going tighter. Eventually, an infinitely curved space corresponds to zero spatial volume. Let me ask you a question, Mr. Scientific Materialist. How much stuff can you put in no space? It's funny, but it's also a profound question. You see, I mean, it raises the Hawking-Penrose singularity theorem, as it's called, has posed, I think, a very formidable challenge to the whole worldview of scientific materialism. Because its implication is that if there's a 0 point for time, a singularity in time and space, it also implies that the universe comes out of literally nothing physical. It's like the view of the medieval theologians who believed in the doctrine of creatio ex nihilo, creation out of nothing physical. And that's what we're coming to in modern physics and cosmology. It's profound. I think it also creates the basis of a reformulation of an ancient argument called the Cosmological Argument. Because if you want to explain the origin of the universe, the cosmological argument was the argument that it's the first cause argument. Everything that begins to exist has a cause. The universe began to exist, therefore the universe must have a cause beyond itself. We call that cause God. It's an ancient argument. During the Enlightenment, the philosophers questioned this because no one was sure about the second premise, that the universe began to exist. If the universe began to exist in time and space and matter and energy, then to explain the origin of the universe, to give a causal explanation for the origin of the universe, we need to invoke a cause that transcends matter, space, time, and energy. And of the possible entities we could think of that has that profile, God kind of comes to the top of the list, okay? We need a transcendent cause of great power to bring the universe into existence. So the cosmological argument is back on the table as a result of these new developments in cosmology. Obviously, there's a connection to the biblical point of view as well. The first words of Genesis are, after all, not in the eternity past, okay? So very interesting. One other thing, connection, if you're a Christian, in the New Testament you have the idea that the plan of God existed from before the beginning of time, which implicitly, and this is referred to twice, which implies that time itself is a created entity, which is kind of what physics and cosmology is now indicating as well. Time itself had a beginning. So, profound stuff. Now, that's discovery number one. Let me give you two other things here. I won't take quite as much time on these, but they're equally exciting. And so we have evidence of a transcendent cause and a definite beginning for the universe. But in physics, there's another discovery that's been made that gives us more information about that transcendent cause, if you will. It's the discovery of what's known as the fine-tuning of the laws and constants of physics, as well as the initial conditions of matter at that first millisecond after the origin of the universe. Let me explain. If we think about that, here's an illustration of what the physicists are talking about. Let's just take the expansion rate of the universe. Turns out if the universe were expanding even a little bit faster or a little bit slower, we would either have what's called, if it was a little slower, we'd have a gravitational recollapse where everything would fall back onto itself. If it was going a little bit faster, the matter in the universe would dissipate too quickly, and we would end up with what's called the heat death of the universe. And it further turns out that the expansion rate of the universe is exquisitely finely tuned to about 1 part in 10 to the 60th power. That's 1 part in a trillion, okay? Now, I grant you not much in comparison to the federal budget deficit, but pretty impressive nonetheless. If you're an engineer and you're familiar with the notion of tolerances, The fine-tuning of this one parameter that makes life possible is within an exquisite finely tuned tolerance, very small tolerance for error. It's got to be right on the bullseye, okay? Now, I may not have made this point clear. Why is the fine-tuning important? Well, because if things were even a little bit different, a little too fast, a little too slow, the universe would not be a suitable place for life. Life depends on these fine-tuning parameters. Think of it as the Goldilocks universe. Not too hot, not too cold. Not too fast, not too slow. Not too big, not too small. Forces not too strong, not too weak. Everything delicately balanced to make life possible. Okay? And there are about 36 of these fine-tuning parameters that have been discovered at the fundamental level in physics. Things like the strength of gravitational attraction, the gravitational force constant, as the physicists refer to it, the speed of light, the ratio of other fundamental forces, and on it goes. So there are lots of these parameters, and one physicist has likened this to, he asked you to get a handle on what's going on, he asked you to imagine that you've gone into the universe-creating machine. You're out in space traveling around with the Starship Enterprise or something. Do they still do that? I think that's old. Anyway, you're out in space and you come across this space station and it says universe-creating machine. So you're a physicist, you want to know how it was done, you're curious, you go inside and you find there's this panel with all these dials and knobs, and each one of them is set to a very precise value for all these fundamental forces and parameters of the universe. And so you whip out your pencil, you're a physicist, and you make some calculations, and you realize that if you changed any one of those dials or sliders or knobs by one click, either way, for various reasons, life would be impossible in the universe. And this physicist, John Polkinghorne in Great Britain, says, he says, what do you make of that? He has an understated British answer. He says, well, I don't say that the atheists are stupid. He says, I would say that the theistic design hypothesis provides a more satisfying explanation. Okay. Another British physicist that I had the good fortune to meet when I was a graduate student, Sir Fred Hoyle, put it this way. He said, a common sense interpretation of the data suggests that a super intellect has monkeyed with physics and chemistry to make life possible. I like the way the monkeys always make it into the origins debate, even in physics, okay? So that's another huge development in modern science that was completely unforeseen in the 19th century. The very fabric of the universe, the laws, the fundamental laws and forces and constants of physics are exquisitely finely tuned to make life possible. And a common sense interpretation of that suggests design. Suggests not just a transcendent cause, but an intelligent cause that operated from the very beginning. Okay? Now, the next area is the area that most fascinates me, and that is the area of the evidence of design in biology. And it's the whole question of the origin of information. If you want to give your computer a new function, what do you have to give it? Code? Code? Yeah, very good. Code, information, software. Well, it turns out that the same thing is true in life. And we've come to appreciate this since the discovery of the structure of the double helix by Watson and Crick in 1953, and all the amazing discoveries that happened in the immediate wake of that. Along the spine of the DNA molecule are 4 chemicals called bases, or sometimes called, technically they're nucleotide bases. And Francis Crick, who was the co-discoverer of the structure of DNA, suggested in 1957 something he called the sequence hypothesis. And the idea of this is that these 4 chemicals, the nucleotide bases, convey information for building all the proteins and protein machines that our bodies need to stay alive, that every cell in every living organism needs to stay alive. The machinery of life is made of proteins. The proteins are built, Crick suggested, in accord with instructions that are stored on the DNA molecule. That the DNA molecule is literally storing digital code. And those bases that store the information are functioning much like alphabetic letters in a written language or digital characters in a machine code, which is to say it's not the chemical properties of these chemical subunits in DNA that matter, it's their arrangement. Think of Scrabble letters on a board. You've got a pile of them, they don't do you any good. But if you arrange them properly, you can get the triple word score. You can convey a meaning. Well, if the nucleotide bases along the spine, on the spine of the DNA molecule, and they're represented, chemists actually represent them with the letters A, C, G, and T. If they're arranged properly, they provide instructions for the cell so that it knows how to build these important proteins and protein machines that the cell needs to stay alive. The closest analogy is to something that goes on up in Seattle, where I'm from, at the Boeing plant. And engineers will be familiar with this as well. It's a technology called CAD/CAM, Computer-Assisted Design and Engineering. Computer engineer or electrical or mechanical engineer will sit at a console. Maybe he's trying to design a wing for an airplane. He'll make some selections of some parameters. Those selections will be literally codified into digital form. That digital information will be sent down a wire. It will be translated into a machine language that can be read by an assembly arm, and then that information will direct, for example, maybe the riveting arm to put the rivets on the right place on the airplane. Digital information being used to direct the construction of mechanical parts. Ford uses it. All kinds of companies use this technology now. Guess where else it's being used? Inside the cell. Even in little bacterial cells. We've got high tech in low life. I mean, it's incredible. So this is the big discovery of late 20th century biology, is that information is running the show in life, in even the simplest cells, and that the information revolution that we talk about in our own high-tech world has been already at work since the beginning of life itself. So now, what do we make of all of this? And turns out that the discovery of information in living systems creates a huge mystery. And it's not the mystery of the structure of DNA. Watson and Crick solved that problem. I call this mystery, by the way, the DNA Enigma. And the DNA Enigma is not the structure of the DNA molecule. Watson and Crick figured that out. They elucidated the structure of DNA. It's not where the information for building proteins resides. We know where that information is stored. It's stored in the DNA molecule. It's not even what that information does. We know what the information does. Like the CAD/CAM plant, the information directs the construction of the protein parts. What's the mystery surrounding that information? It's the mystery of where it came from. It's the mystery of origins. It's the mystery of the ultimate origin of that information. And so the discovery of the information in DNA is closely linked to another mystery in science, another issue in science, and that's the question of the origin of life itself. Because to build life, you've got to have the information in DNA to build the parts that life needs to survive. Just like with your computer, you want your computer to have a new function, you need to provide it with code. If you want to build a living cell in the first place, you've got to have the information, the instructions for building the parts of the cell that it needs to stay alive. So you want to explain the origin of life? You got to explain the origin of information. And the quote behind me is from a scientist saying this. Now, I first encountered this DNA Enigma in 1985. I was a young scientist. I was working in the oil industry at the time. And I went to a conference where there was a scientist, it was a discussion of the origin of the universe, the origin of life, and the origin and nature of human consciousness, some of the big worldview questions that arise in the scientific disciplines. And there was a scientist there who had just written a book called The Mystery of Life's Origin. And at this conference, all the scientists discussing the origin of life were agreed that no one had an adequate evolutionary explanation for the origin of the first life. Now, this shocked me. I was under the impression that the evolutionary biologists had this question all sewn up. I'd read the textbooks, after all. But the leading people in the field were openly acknowledging that this was a profound mystery. Now, as it happened, I got to know one of the scientists who was there. A mutual friend introduced us. His name was Charles Thaxton. He'd written a book called The Mystery of Life's Origin, in which he laid out chapter and verse the difficulties attendant attempts to explain the origin of even the simplest living cell by undirected chemical evolutionary processes. And the biggest difficulty of them all was the problem of the origin of information. All attempts to account for it from purely physics and chemistry, undirected natural forces had failed. And Thaxton had begun to entertain the idea in the epilogue to this book that perhaps the information in the DNA at the foundation of life was actually an indicator of what he called an intelligent cause. After all, information is the kind of thing that minds produce. It was an intuitive connection for him, but one he thought he needed to propose. Now, I began to get to know him better. He mentored me, and a year later I was off to grad school, and I had a burning question in the back of my mind, and that was, could you make an argument for this idea of an intelligent cause, or the design hypothesis, or what later became known as the idea of intelligent design? Could you make an argument, could you make a rigorous scientific argument for the design hypothesis? And as I embarked on my graduate studies, I eventually came to the works of Charles Darwin. And Darwin's work was very important in helping me answer this question, because Darwin was using a method of scientific reasoning that helped scientists investigate events in the remote past. The origin of life was, after all, an event in the remote past. And Darwin's method suggested that scientists, because we can't observe what happened a long time ago, we have to infer it. And what we want to infer is that possible explanation which would best explain the data. It's a method called the inference to the best explanation, or sometimes called the method of multiple competing hypotheses. But that led me to another question, which was, what constitutes the best explanation when you're trying to explain an event in the remote past? And one day I was reading one of the scientists who had been an influence in Darwin's life, and the light went on. This scientist was named Charles Lyell. He was a famous geologist, and he said that when you're trying to figure out what happened a long time ago, we should, and he was talking specifically about geology, but the method applies to all the historical sciences. He said we should be looking for causes that are now in operation. In other words, we should explain events in the remote past by causes that we know from our present experience have the power to produce those events. If you're in eastern Washington and you're a geologist and you find a layer of white ash, well, you could posit that it was an earthquake, or that maybe a flood did it, or maybe a volcanic eruption. Which one of those three is best? Obviously the volcanic eruption. Why? Because of what we know from our present experience. We know that volcanoes produce layers of ash, and we've never seen an earthquake or a flood do that. So using this same method of reasoning, I suddenly realized that it was possible to make a rigorous scientific argument for intelligent design, rather mischievously actually using Darwin's own method of reasoning. Because if you begin to think about what we know from our ordinary and repeated experience, from our present experience about what it takes to create information, it turns out that there's only one known cause of the origin of information, and that is intelligence. It's mind, not an undirected material process. Another scientist I was reading at the time put it this way. He said the creation of information is habitually associated with conscious activity. Well, that's right if you think about it. Bill Gates has said that DNA is like a software program, only much more complex than any we've ever written. How do they build software at Microsoft? Not by wind and erosion. No, some people have issues with but never mind that, okay? Generally, it takes a programmer to make a program, right? In fact, more generally, whenever we find information and we trace it back to its ultimate source, we always come to a mind, not a material process, whether we're talking about a hieroglyphic inscription or a newspaper headline or information embedded in a radio signal or information in a software program. Whenever we trace it back to its ultimate source, we always come to an intelligent designer, to a mind, not an undirected material process. So the discovery that at the foundation of life there is information, and that to get life going in the first place you have to have information, points to an intelligence at the foundation of life. It points to the need for intelligent design as the best explanation for the origin of life itself. And now notice, in reasoning that way, I'm using Darwin's own method of reasoning to come to a decidedly non-Darwinian conclusion, which is that there is actually evidence of design in biology. And that's the argument I make in Signature in the Cell in much more detail. Now, what do you get when you pull all these strands of evidence together? Well, we see that there's evidence of a definite beginning to the universe, which seems to point to the need for a transcendent cause beyond matter, space, time, and energy. We also see that there's evidence of a designing intelligence, of design from the very beginning of the universe, with the fine-tuning of the laws of physics and chemistry. But we also see that there's evidence of design that arises well after the beginning of the universe in the history of life, suggesting that that designing intelligence also is active in the creation, not a deistic intelligence or a deistic creator that only acted at the beginning, but an intelligence who acts at the beginning, but also in time as well. And so when you pull those strands of evidence together, I argue that the best explanation is actually a theistic design hypothesis, or the idea that God exists. The reality of God explains the cosmological, the evidence of the definite beginning, the cosmological and fine-tuning, as well as the origin of information in DNA. In other words, I hold to intelligent design, but I also, upon further deliberation about the whole ensemble of evidence that science is now presenting us, believe that the best explanation for the identity of the designer is a designer who has the attributes that Jews and Christians and the Bible itself has long attributed to God himself: transcendence, intelligence, and immanence, activity within the creation. So I think it's a very exciting time to be a person of faith who is also into science. Far from the testimony of the new atheists who say that science makes belief in God untenable or delusional, I think that St. Paul was right, that the things that are made do reveal the reality of the Creator. And it's interesting, even many secular scientists and historians of science are now acknowledging this. One, Frederick Burnham, historian of science, says this. He says, the idea that God created the universe is a more respectable hypothesis today than at any time in the last 100 years. I don't think it's just a respectable hypothesis. I think it actually provides the best explanation for this ensemble of evidence that has come from physics, chemistry, and biology from, as St. Paul says, the things that are made. And so I think the God hypothesis is back, and I thank you very much.